This is homework 10, however, it is a very good test review. So let's go over each one of these. For the first part, notice you have log 11 on both sides. So you can really think of these, the only way it can be equal is for these two parts to be equal. So we're going to say 4y minus 7 equals 15 plus 2y. And so here, solving this, we're going to have 2y equals 22, so y is 11. Now you do need to go back and plug into both places here to make sure you have a positive value once you do substitute in, and very quickly we say that you do. Okay, our next problem, again going through the same process, and over on this other side we see that this 1/2, we're going to have to move that up to be an exponent first before we can do anything. And so when we put all of our parts together here, we have p plus 5 equals 1 minus p all raised to the 1/2 power. Now to get rid of that 1/2 power, we are going to square both sides. The square here and here. And so that's going to give me p plus 5 all squared equals 1 minus p. Now here we need to FOIL this out. Remember, p plus 5 all squared is p plus 5 times p plus 5. And that equals 1 minus p. So that's going to give us p squared plus 10p plus 25 equals 1 minus p. So getting everything together on one side, and we know to do that because we have a squared term, we're going to add p over, so that's going to give me 11p plus, and if I subtract 1 over, I'm going to have 24, and all of that equals 0. So now we need to factor this, and it looks like the factors a 24, 8, and 3. We need to add those to get positive 11. So we're going to have p plus 8 times p plus 3. That equals 0. And solving, we get p is negative 8 or p is negative 3. Now we do need to check these solutions to make sure that our argument here does stay positive. And unfortunately, if we plug in negative 8, we're going to have negative 8 plus 5, which is less than 0. So negative 8 will be tossed out. However, if we plug in negative 3 plus 5, that is greater than 0. And so let's go on over to the other side. 1 minus negative 3, that is also greater than 0. So we see that p minus 3 should be the correct answer. Okay, now this type of problem, we are going to have to condense first before we do anything else. And so notice we are separated with subtraction. So this will go together with division. So I have log 7 of 2x minus 1 over 3x minus 8. And that's going to be equal to log base 7 of 5. Now that we have those condensed together, we really can remove the logarithm or set the arguments equal to each other. So 2x minus 1 over 3x minus 8 is going to have to be equal to 5. And I would put 5 over 1 to set up our proportion. You'll need to cross multiply. So that's 2x minus 1 equals 5 times 3x minus 8. So we do have our distributive property here. We're going to have 15x minus 40. And we're going to subtract our 15 over. And of course, you can solve this anyway. I always just move my x's over to the left side. So we're going to have negative 13x, and I'm going to add 1 over, equals negative 39. And so x is going to be positive 3. And again, going back up and double checking, notice if we do plug in 3, everything stays positive, so that'll work. All right, so for our next problem, even though this is ln, keep in mind, still a logarithm, it's just the base is e. And so we have ln. We're separated with addition, so we're going to put these together with multiplication equals natural log 6. And again, now that they're condensed, we have n plus 7 times n plus 2 is equal to 6. So we're going to have n squared plus, and that's going to be 2n and 7n, so 9n plus 14 equals 6. We have a squared term, so that means we need to move our 6 over. So we have n squared plus 9n plus 8 equals 0. And so the factors of 8 that'll add and give us 9, well, that's going to be 1 and 8. So we're going to factor this into n plus 1 times n plus 8. That equals 0. And again, we're going to get a negative 1 or n is negative 8. And we do need to check that, especially with both of those being negative. It looks like negative 8 is not going to work. If I sub in negative 8 here, that's going to give me a negative 1. So we throw out the negative 8, and so n equals negative 1. All right, for our next problem. Okay, this problem's a little bit different because we don't have a logarithm on each side. Now, our variable is here, so that is really locked in because of the logarithm there. We are going to start by subtracting 4 from both sides. And so we have log base 5 of 7k minus 3 equals 2. Now, we're going to go ahead and rewrite this in exponential form because that's the only way we can access that variable. So we're going to say 5 raised to the second power is equal to this argument here, 7k minus 3. We always will go back to that exponential power or that exponential form whenever we only have logarithm on one side. All right, so solving this equation, that's going to give us 25 equals 7k plus 3, or minus 3. We're going to add 3 over, so we have 28 equals 7k. Dividing both sides by 7, we see that k is 4. And a quick glance up at the top, we'll see that that can be an answer. So here we have our final answer. All right, so with this problem, again, a little different. We've got a lot of operations here. And notice inside the braces, we have this. So let's go ahead and put that together first. So we have 2 times, and this is separated with addition. So we're going to put that together with multiplication. And so it's going to be 2 times c plus 1. And then that's equal to 3. And notice there's nothing else to combine here, so we need to go ahead and divide both sides by 2 to get that 2 to move over to the other side. And so that's going to give me log 4 of 2 times c plus 1, and that's going to equal 3/2. And again, notice we only have a logarithm on one side, so we need to go to that exponential form again. Here's my base. Remember, all logarithms are equal to exponents, so 4 raised to the 3/2 is going to be equal to 2 times c plus 1. So 4 raised to the 3/2 is going to be 2c plus 2. Now, a bit of review here. 4 to the 3/2, that means the square root of 4, which is 8, or square root of 4, which is 2. 2 to the third is 8, equals 2c plus 2. And so we're going to have 6 equals 2c, so it looks like c is going to be 3. All right, very similar to the previous problem, we are going to go ahead and put these things together. Now we do need to move that up, and so that's going to be our a squared. So we're going to go ahead and write that in, And then we have addition, so we're going to put that together with multiplication. So we have log base 16, and then it's going to be 9 times a squared, and that's going to be equal to 3/2. And again, since we only have logarithm on one side, this is where we went to our exponential form. So we're going to have 16 raised to our 3/2 equals 9a squared. And again, here, 16 to the 3/2, that means the square root of 16. And that's going to give us 4. And then we're going to raise that to the third power. 4 to the third power is 64. So we have 64 equals 9a squared. Now you have two ways to do this. You can subtract your 64 over, and that's one way. And if we subtract that over, then we're going to have 0 equals 9a squared minus 64. And again, with two terms, you're going to factor this. And the only way it'll factor is that something squared? Is that something squared? And it is. Square root of 9a squared is 3a. So 3a and 3a. Square root of 64 is 8. And then one's positive and one's negative. So we set each part equal to 0. So 3a minus 8 equals 0. And 3a plus 8 equals 0. So here we're going to see that a is going to be 8 over 3, or a is negative 8 over 3. Now the other way we could have done this is from here we could have taken our 64 equals 9a squared. We can divide both sides by 9. And so 64 over 9 equals a squared. And then take the square root of both sides. The only thing in doing this is you need to make sure you do plus or minus. And then you have plus or minus square root of 64 over square root of 9. And you get the same exact answers. Now you do need to go back up and check. And notice that 9 is going to be positive no matter what we sub in. But this a here is not. Remember, originally, even though we rewrote that to be a squared, originally it was not a squared. It was just an a there. So what we're going to have to do is toss out that negative 8/3, because it would make a portion of the problem negative. And so here our answer is positive 8/3. All right, more of the same here. So it does look like we need to move. This 1/4 is going to have to be moved up to be the exponent of 256. And so here, when we do that, we have the natural log of 256 raised to the 1/4 power plus natural log of u equals 6. And the fourth root, that's what the 1/4, that means fourth root of 256, that's going to be 4, I want to say, plus natural log u equals 6. And so putting this together with multiplication, we have the natural log of 4 times u equals 6. And then we're going to have to remove that natural log. And again, remember, and it's okay to rewrite this, that is log base e of 4u equals 6. And so going to our exponential form, then that's going to say e raised to the 6th power equals 4u. And then dividing both sides by 4. And you can leave this in exact form or type it in the calculators. You have e to the 6th all over 4. And that is positive, and looking up here, that would be okay to have a value like that for u. All right, next problem. Now these are the types of problems where we had to change our bases. Now we could not change the value of the base. We had to change what it looked like. And with 243 and 9, we could rewrite both of these to be 3 to some power. and that's how we knew which base to use. So that's going to be 3 to the 5th and times, because you have an exponent raised to an exponent, equals 3 squared, and that's going to be times our p plus 2. So this is going to be 10p equals 2p plus 4. I'm going to subtract our 2p over, so 8p equals 4. I'm going to divide both sides by 8, and so p is 1/2. Alright, and there wasn't any need for these for us to check our answers. It was just with the logarithms. Okay, for our next problem, notice both of these look like it's probably 5 to some power. So we're going to try to rewrite those. Now, 1 over 625, we do need to flip that over. So we're going to say that's really 5 to the negative 4. And then that's going to be times the exponent that's already there, equals 5 to the 3rd times that exponent that's already there. And so now that we have our same bases, let's go ahead and multiply those. That's going to be 12n equals, and our distributive property over here on the other side, I'm going to subtract 3n over. And so we have 9n equals negative 6. And so n is going to be negative 2 over 3. And again, it is okay for these to be negative. We don't have to worry about checking those. All right, our next problem. Now, this one is different from the previous ones because there's no way to rewrite 14 to some power and get 3. It's not going to happen where we could rewrite the others. So this is where we had to take the log of both sides so that we can move this down to the front. So we're going to say log 3 raised to the 2r minus 5 equals log 14. And then we're going to take all of this and move it down to the front. So we're going to have 2r minus 5, and that's going to be times log 3 equals log 14. And since we don't have another variable on the other side, it was okay for us to go ahead and divide by log 3. And so we have 2r minus 5 equals log 14 over log 3. And we're going to add our 5 over and then divide by 2. So we're going to have 2r equals, now this is where we could incorporate that change of base formula. We can keep writing that, or we can say this is really the same thing as log base 3. The base is the bottom number, and then the top is your argument. So log base 3 of 14. Now if you don't want to do that, you don't have to. It's just a little bit less writing. And then we're going to divide both sides by 2. And so here's what you would type in the calculator. And your test will be calculator active, so make sure you know how to plug those in. Right, our next problem, we do not have our exponential term by itself on one side. So we're going to have to divide by 5 first to get it by itself. So here we're dividing, and so we're going to have 17 raised to the 1 minus 3x, and that's going to be equal to 4. Now we're ready to do log of both sides, so we're going to do log 17 1 minus 3x equals log 4. And again, we're going to move this down to the front, so we have 1 minus 3x times log 17 equals log 4. And since we only have one variable on one side, we're going to divide both sides by log 17. And then we're going to go through, and here's where I would definitely rewrite, but you don't have to. I would make that log base 17 of 4. And then I'm going to subtract 1 over. So I have negative 3x equals log base 17 of 4 minus 1. and then divide both sides by -3. And again, this is the portion that you would type in your calculators. Okay, with this problem, we definitely do not have our exponential term isolated yet. So starting with adding 8 over, so we're going to have 2/5 times 4 to the 5v equals 12. And now we're going to divide by 2/5, which is the same as multiplying by 5/2. And let's see, we make sure all that cancels. We have 4 raised to the 5v equals, we can put 12 over 1 and we will cancel. And so that's going to leave us with 30. Now we're back to the types of problems we've been working with. And so we're going to do the log of both sides. And then that's going to allow us to move our exponent down. So 5v times log 4 equals log 30. And again, we're going to go through and divide both sides by log 4. Okay, and so we have 5v, and again, you can do your change of base formula here to save you some writing. And then we're going to divide both sides by 5. And you're finished. Just type this portion in your calculators. And again, we need to do some more rearranging. So with this one, it looks like we need to subtract 11 over. So I have -3 times 4 to the 2y plus 9 equals -15. I'm going to go ahead and divide both sides by -3. And so we're going to have 4 raised to the 2y plus 9 equals +5. Now we're going to do the log of both sides. And so that's going to be, again, what's going to allow us to move our exponent down. Equals log 5. And when we move this down, we have 2y plus 9. And that's going to be times log 4 equals log 5. I'm going to go ahead and divide by log 4 simply because I do not have a variable on this other side. And so I'm going to have 2y plus 9 equals log, and again I'm going to use my change of base formula, log base 4 of 5. And finishing out the problem, we'll need to subtract over 9. And then divide every part by 2. All right, next problem. All right, now this one is the one that's a little bit more difficult than the others. And what's making it more difficult is the fact that you have these on both sides. So that's going to make things a little bit different for us. So again, this is isolated as best as it can be right now. So we're going to go ahead and jump straight to doing the log of both sides. And that's going to give me c plus 6 equals log 4 to the 2 minus c. And I'm also going to move this c plus 6 down to the front. And this is where it's going to change a little bit. We're not going to be able to go ahead and just divide both sides by a logarithm simply because we have this on both sides. So we're actually going to have to do our distributive property. Now nothing is going to combine, so that's what makes it look terrible, is you're just rewriting all of this. 6 log 3. And the same is true on the other side. So you're going to have 2 log 4 minus c log 4. Now you need to get the terms that have c in them. We're going to move those to the left of the equation, and the ones that don't have c in it, let's move those to the right. So, and again, there's nothing that you can combine, so it's just a lot of rewriting this stuff. So that's going to be plus c log 4. You cannot combine those, even though both of those are c, this log value is different, so we really can't combine those. over here on the other side, we have 2 log 4 minus 6 log 3. Now what we're going to do here is we're going to factor out that c. And when we do that, we're going to have log 3 plus log 4. Now we could combine those, but it's really not necessary for this because we are going to just transfer all of this to the calculators. And now you're going to divide by log 3 plus log 4, or if you just wanted to do log 12, that would also work. So do make sure you use your fraction key on the calculators because it will make typing this in a little bit easier. And so once you have all of that typed in, that's going to be your final answer. Okay, and the next problem is just like that. Again, we're going to go ahead and start by doing the logarithm of both sides and moving down these exponents. So that's going to be 2k plus 3 times log 8 equals 3k minus 1 times log 6. And again, we cannot divide by that log because of the variables. So we're going to do our distributive property and nothing's going to combine. So we're just rewriting a lot of this. Plus 3 log 8 equals 3k log 6 minus log 6. And again, let's move everything that has a k in it on one side. So that means I'm going to subtract this 3k log 6. And then move everything else over to the other side. We already had a negative log 6, and then I'm subtracting 3 log 8. And now we're to the part where we do need to take out that GCF, and that should be the case for just about every one of these. And this is the part where you're welcome to use your logarithm properties and combine them, but it's really not necessary. Alright, and then your last step would be to divide. So we're dividing by 2 log 8 minus 3 log 6. And then over on this other side, same thing. We're going to divide by 2 log 8 minus 3 log 6. And again, this whole part here, that is what you need to be typing in the calculators.